To start things off, when we think about the smart monitoring, it is easy to focus purely on the hardware and the code. But in reality, implementing a system like this can have a massive ripple effect across five major areas, which is societal, health, safety, legal, and cultural. Firstly, in societal, it can boost crop yields while cutting water and energy waste. Next, health, which is keep air clean and prevent toxic mold growth. Next one is the safety. Trigger instant backup like a fence and buzzer during the race. After that is the legal, which is lock automated data for easy compliance record. Lastly is cultural, which can upgrade traditional farming into high-tech career.
To understand why this project is necessary, we must first look at the challenges in greenhouse tomato cultivation. Tomato plants are extremely sensitive to the environment. If factors like temperature, humidity, and carbon dioxide levels are not strictly controlled, it can lead to crop growth and a significant decline in both the quality and quantity of the harvest. Currently, many farmers rely on traditional manual monitoring. This creates a major problem for the industry. As you can see here, there are three primary issues and solutions we are addressing. First, traditional manual monitoring is labor intensive and prone to human error. Due to a lack of manpower, farmers struggle to monitor growth continuously, meaning harmful environmental changes often go unnoticed for extended periods. Second, our project introduced an IoT-based monitoring system that provides real-time data. This system continuously tracks critical environmental parameters, ensuring there are no sudden shifts go undetected. Finally, the system improves decision-making through an automated process by automatically triggering actions like activating exhaust fans or sending alerts. We help farmers respond quickly, reduce their reliance on manual labor, and maintain the stable environment needed for healthier tomato growth.
Moving on to what we actually set out to achieve in this project, we focus on our effort around three core objectives. Firstly, to design an IoT-based monitoring system that monitor the environmental input. Secondly, to design and develop a ThinkSport dashboard for real-time data visualization and monitoring. And lastly is to analyze how automated monitoring improve decision making compared to traditional manual method.
To conclude, this project successfully demonstrated the development of an IoT-based smart monitoring system tailored for greenhouse tomato cultivation. We have achieved several key milestones. First, we developed an automated IoT system that replaces labor-intensive manual inspection with a robust data-driven framework. These transitions allow for much more consistent and reliable oversight of the growing environment. Second, we utilize the ThinkSpot dashboard and Jupyter Analytics to provide real-time visualization. By processing data through a virtual pipeline supported by historical datasets, we have enabled faster and more informed decision-making for farmers. Third, we implemented automated conditional logic to trigger essential responses like ventilation and system alerts. This significantly reduced the risk of crop spoilage and by ensuring that ideal environmental conditions are maintained automatically. Finally, we have designed this system for future scalability. Future iterations could incorporate automated precision irrigation through soil moisture sensors and leverage artificial intelligence for predictive climate management. In this model, the AI will offer optimal interventions while farmers retain the final authority on all actions. And that is all from us. Thank you.
Assalamualaikum and greetings to Madam Roslina and my fellow friends. Today I'm going to be presenting on our group assignment for ECE523, which is Introduction to IoT and Data Analytics. Today I'm going to be talking and discussing about our two methodology that we use in our project. Our project has been titled as Tomato Monitoring System, and our first methodology is by utilizing Google Colab, and our second is by using ThinkSpot. First, I'm going to show you what we have done by using our Google Colab, our coding. Now we're going to our first code, which is by installing Paho MQTT. This is used to install MQTT pathway that we're going to be using to connect with ThinkSpot. We use MQTT because it provides us with low latency while for transferring data. When we go to second line, we will see here is first one is to import Paho MQTT client, which is to provide the client side tools they need to connect and publish data on MQTT brokers such as ThinkSpot earlier. And then we're going to be importing time, which is used for synchronization and delay while transferring the data, so that the data will not be too fast when we're transferring. Then we're going to be importing library JSON, which is to use to structure telemetry payload in a standard data interchange format. And lastly is to import pandas, which is used to parse, manipulate, and extract dataset from CSV file that we're going to be using. We're going to be taking the data for our project from. Then we go to the third coding, which is here. The first we do here is to access the token. The token here is the token that we'll be taking from our ThinkSpot, which is our ThinkSpot token ID, used to connect with the device that we have created in our ThinkSpot. Then this here is used to connect with our telemetry attribute and to read and access the CSV file that we use in our project here. Next, we're gonna be loading the CSV. Here is the coding we use so that we can access the data in our CSV file. When we have successfully accessed the data, it is print successfully loaded. And if we cannot find the file or cannot find any data inside the file, it will say could not find. Then we'll be moving to our next coding, which is where we read what we want to read from our CSV file and where it will be placed. It is placed in the CSV file. The first one, the data we want is indoor temperature. Next is indoor humidity, and lastly is indoor carbon dioxide. This is the three data that we want to collect and extract from our CSV file and that we'll be using in our project and send it to ThinkSpot later on. Then we'll be moving to the next coding, which is client. This is used so that we can connect to our ThinkSpot. Then next is it will print when we have been connected to our ThinkSpot. It will be say connected to ThinkSpot MQTT broker, and when it failed, the connection failed, it will be print could not connect to ThinkSpot MQTT broker, and it be going until the connection will be keep on going to keep it alive. Then we'll be setting alarm for this part. Here we set alarm so that when the temperature or humidity and carbon dioxide is not fall below or above the value that is suitable for growing tomato, it will initiate the alarm later on. Then I'll be going to the next one, the next part, the next coding. Here is we structure how we want to send our data in our coding in our ThinkSpot later on. We'll be doing some looping, we'll be doing some filtering, and we're doing some logic in here, and how we want the data to be displayed, how we want the data to initiate the alarm later on in our ThinkSpot. Here you can see that we have set when the temperature is too high, then 30 degrees, it will send warning or alert the alarm making the sound, and else it will be, which is lower than 30, it will be safe level, which will clear the alarm and reset the alarm. Okay. Lastly, I'll be going, the last part here is we start sending the data to our ThinkSpot. Okay, then that's all for our Google Colab. We'll be moving to our ThinkSpot. This is the initial dashboard for our ThinkSpot. First we see for our device, it is in inactive state because we haven't sent the data yet. We haven't run our Google Colab coding earlier. This is why there are some value here on our dashboard, is because we do a test run first to check whether our coding and how we send our data is work properly or not. Okay, now we're gonna be start sending our data. We're gonna be running our code one by one. Here, start with the first one. Okay, the first one done. Okay, we start with the second coding and third coding. Now go to the fourth coding, the fifth coding, sixth coding, seven. Next one, we run everything first, and the last one where it will start sending data to ThinkSpot. So we're gonna start sending it now. We have already started, and here it still say inactive because I haven't refreshed my ThinkSpot. So now we refresh it, and we can see the status change to active. We're gonna start. We can see our dashboard now will be flowing with the new value. We update our value every 5 seconds to keep it slow so that it will not crash if it's too fast. So you can see here it will be moving, and when the temperature is more than 30 degrees, the alarm and exhaust fan will be turned on to cool down and to alert the owner of the farm. When the temperature lowered to under 30, it will be refresh the alarm and the exhaust fan will be turned off. Here we can see the temperature level. Here we can see the carbon dioxide level, and lastly here we can see the humidity level. This is our exhaust fan, and this is our alarm buzzer. This is the chart we use to see how our data get in our project. You can see the level, whether it's steady or not. I think that's all from me. Thank you very much.